Hi Lini, how is it going with Bean Talk?
Hi, very good. Very good. We've had a lot of really interesting people to talk to over the past few weeks.
Which episode is today?
The 6th.
Wow, the 6th episode.
Yeah, time flies, huh?
Unbelievable, yes. Who's your guest today?
Alessandro Craparo, who is a scientist and climatologist from South Africa, and he did a really interesting TED Talk about coffee and climate change a couple of years ago, and we had a really interesting conversation with him.
Is he the owner from Science Coffee in South Africa?
Yeah, exactly, that's him.
So I don't know him, but I know this roastery Science Coffee and the coffee shop. It's a very, very cool coffee shop. I was been there in 2018, and it's great. Do you know who is working there now?
I don't.
Brad?
I think. Oh yeah, sure, of course. Yeah.
Brad. He was in Austria and was trained by Benjamin in barista course and also in the Mumak Academy in Italy.
He actually gave me the contact, so what a coincidence.
What a coincidence.
Yeah, but I'd say let's watch the interview.
Let's watch.
Maybe to start, tell us a little bit about yourself and what you're working on.
Cool. Okay, perfect. So thanks very much. So my name is Alessandro. I'm a scientist at Biodiversity Seat Alliance. So we're an international research institute who work on a number of different plants and crops throughout the globe and a number of different themes. So climate change is one of them. I'm within that sphere, so we work to understand how the environment influences the plant, essentially, coffee being one of those plants.
But you do also own your own coffee shop, right? Science of Coffee?
Correct. So I own a coffee roastery as well. So that came out of my PhD. So I started my work and research in East Africa, in Tanzania, Ethiopia, Uganda. And along with all the research, I of course came across some beautiful farms, some beautiful farmers, some really nice coffees. And it would be sin, of course, not to play with them. So I smuggled some back every year in my bags and played around with the roasting. And then effectively, that's how Science of Coffee started. So the roastery, we still buy from much of the same farmers that I used to work with. And we roast coffee and then deliver to mostly all over Southern Africa.
Okay, so your interest for coffee came out of your research and not the other way around. That's very cool. Now, are you focusing your research mainly on coffee or a variety of different plants?
Yeah, so actually, we currently, personally myself, still on coffee, but we're moving into a bunch of different plants as well. Cocoa being one of them, and also into bigger climate impacts. So not just crop plants, but also linking the poles and the tropics. So for instance, if you want to understand how the climate is going to influence your plant or your crop, wherever it be planted, we also have to understand how the climate works, right? And what those linkages are. And very often, they're much bigger than the immediate impact in your area. So for instance, if we want to know what the change will be in East Africa where coffee is grown, or Central South America, many of those climatic influences are coming from further north, further south. So there are many links to the Arctic, for instance, the Antarctic, to the oceans. And so we try and unravel this whole dynamic and see how those changes are going to impact the plants.
Specifically with coffee though, if I remember correctly, in your TED Talk, you spoke about how the plant is very temperature sensitive. I think you said there was like a 4-degree window where the plant is actually happy.
Yeah, exactly. Yeah, so coffee's, I'll talk a little bit about the temperature dynamics. So coffee's an interesting crop because many of the species are very sensitive. Out of the 120 odd species around, we only cultivate or drink 2 of them, right? Arabica and Robusta. Those are the 2 commercially available species that we drink. Now, previously it was always considered that Arabica, especially, and Robusta, in fact, were mostly driven by rainfall. So if you could plant and cultivate coffee somewhere and you had irrigation, you'd generally be okay. Because that was considered as one of the biggest limiting factors for producing the coffee. And if you have a drought, for instance, one year, then the production would decline. However, what we found in our research, particularly in East Africa, that was in 2015, 2017, was that in fact temperatures are one of the biggest limiting factors for coffee. And it wasn't just your daytime or your big maximum temperatures, say your heavy effects that happen throughout the day, but it was actually the nighttime temperatures. So coffee is very much like a human in the sense that it's a living organism. So if you keep running day and night, you expend a lot of energy. And effectively what we had found is that if your nighttime temperatures are really warm, the plant doesn't essentially rest or stop. Respiration continues. It uses that external energy, and that would negatively impact your production or your yields. And so that was one of the big findings that came out of our research in East Africa, that actually coffee, particularly Arabica, is very sensitive to temperatures, but not just daytime, also your nighttime temperatures. And recently, last year in 2020, we also published a paper with colleagues out of USQ in Australia that looked at Robusta. And for the first time, we've actually found that Robusta has very similar sensitivities to temperature. So a really nice paper that came out of that as well, that showed that actually it's a good 8 to 9 degrees lower than what we previously thought would be optimal. And interestingly, that because Robusta was always considered the ugly child of coffee, it's the stuff that we throw in instant and we don't really care about it, but it's okay, it's going to save us from climate because it's really robust. Mm-hmm. And this appears not to be the case, especially considering that the optimal range traditionally is thought to be between 22 and 28 degrees Celsius for Robusta. And at around 25 degrees, we found that yields are around 50% lower than they could be if you're below 20 degrees. So Robusta doesn't like heat either.
I see that is going to be a huge issue though, isn't it? Because temperatures are continuously rising. At the end of your talk, you briefly touched upon positioning heat-sensitive cameras to monitor the plants because their core temperature rises when they're in distress, much like with a human. What were the results of that study?
Yeah, so that was also a really nice paper that came out of that. So what we had done with thermal imaging, these cameras that are able to see temperatures, is a very similar thing. And what it mostly related to, or the biggest outcome of this, is that first of all we showed that you can use a camera on a plant, which is pretty cool. That hadn't been done on coffee before. And I guess the bigger thing is that how the plant responds under different shading conditions. So if you think about a plant in typical coffee growing environments, unfortunately over the last 30 to 40 years, we moved very much into full sun systems. So cut down all the shade trees, maximize it. If you get more sun, you get more yield. Now that is true if you can support the plant to produce it. For instance, with fertilizer, with nutrition, with soils, with irrigation. But if you don't have all of those inputs, then the plant productivity would decline. So what we very much also found out of that little experiment is that coffee is a shade-loving plant. It does best under a shaded environment. The conductance, the stamina conductance or the breathability of the plant is much happier within a shaded environment, and you can still maintain yields under a good shade level. So keep shade in coffee effectively.
Are all varieties equally affected though? Or are the new varieties that are constantly being discovered more adapt to the temperature changes because plants are, as you've stated, so adaptable?
Yeah, exactly. So absolutely right. Varieties as well as species are their plasticity is high, so they're able to adapt to different conditions. And so, yes, exactly. Not all varieties are the same. There are certain varieties that are better or well adapted, particularly your new hybrids, where you take specific genes, combine them together, and you will have something that's being able to adapt to a certain condition, whether it's drought or temperature. But in saying that, very recently, there was a really interesting species that had come out of West Africa. I don't know if you had seen this, by Aaron Davis. It made quite a little bit of noise and news He's a colleague who does a lot of research on wild coffee varieties or coffee species. And this particular one is said to be very highly resistant against temperature increases. So it still produces very good tasting coffee, and a lot of it. Coffea stenophylla is the name, and it's out of Sierra Leone. And that's super new. I think it was published last week. And so it's a perfect example that actually there are these species and varieties, and not even engineered ones, wild species that are still growing, that are able to be cultivated and essentially potentially fill a gap if there are declines in coffee production, Arabica or Robusta.
Are those hybrids going to be the future?
Yeah, potentially. At the same time, like we all say, it's a plant, it can adapt. And so there are good things that come out of climate change, where areas that were potentially you couldn't grow coffee now could potentially. The same thing is that we should be exploring and trying to bring back lost species and varieties. And so yes, that could potentially definitely fill a gap in the market and actually use them.
Thank you so much for taking the time and talking to us.
Thanks for having us.
And if you enjoyed our video, hit the button to subscribe, click the bell to be notified for more videos like this, and drop us a like. Bye. Say bye, Amy. Bye. Bye, bye. You just want another treat, don't you?